Okay, 3.7, transformations of linear functions. So starting off, we have a definition that a family of functions is a group of functions with similar characteristics. The most basic function in the family is called the parent function. For non-constant linear functions, the parent function is f of x equals x. The graph of all other non-constant linear functions can be described as transformations of the parent. Starting off with translations, that's whenever you shift it left, right, up, or down. It's a shift of the graph. A horizontal translation, you write it as x minus h within the parentheses, okay? And it's always the opposite of what you think it should be. So a shift of x minus h would be a shift right h. So if it said like h of x minus 1, it would be right 1. A vertical shift is written as f of x plus k, where the x is alone inside the f and then the k is at the end. And the k works as you expect it to. If it's positive, it goes up. If it's negative, it goes down. Example 25, let f of x equals x plus 2. We're supposed to graph A, g of x equals f of x plus 1, and B, t of x equals f of x minus 3. So this one's going to shift it right 3. This one goes up 1. I'm going to graph the original, and then I'm going to graph the new one. So starting off with f of x equals x plus 2, my intercept is at 2, and my slope is 1. So up 1 over 1, down 1, left 1. Here's my original. This is f of x. And then my new one shifts up 1. So I'm just going to take each of these points and go up 1 with them. And there we are. This is g of x. Part B, I'm going to graph the original, which was, what was the original? f of x equals x plus 2. So I'm going to go up 2, and then my slope is 1 over 1. Just like that. Now I'm going to take each of these points and move them right 3. So 1, 2, 3, 1, 2, 3, and then there. This one would be t of x. All right. Next up, reflection on the axes. A reflection is a transformation that flips the graph. We have where we put the negative out front versus the negative inside. If the negative is out front, then it's a reflection over the x-axis. If it's if it's a negative inside, then it's a reflection over the y-axis. So we have, we'll say this is part A, this is part B. Part A, the negative is out front, so that's a reflection over the x-axis. And then the next one, the negative's inside, so that's a y-axis reflection. I'm going to graph the original and then graph the new one, again, just like before. The original has an intercept of 2, and the slope is 1 over 1, just like before. I'll go ahead and graph that on the second one, too. Now, it's an x-axis reflection. This is my x-axis. So each of my points, we'll start off with this one here. It's 1 unit above, so it's going to end up being 1 unit below. And then we have 2 units above, so the next one's 2 units below. And then 3 and 3. So it took this top one and it kind of like flipped it like that. All right, moving on. Y-axis reflection. So that one reflects it over the y-axis, the vertical axis. So starting off with this point here, it's 1 to the left, so I shift it to 1 to the right. The one that's on the axis stays right there, right? You think about whenever you crease a piece of paper, that would be like on the crease. That would be on the line of symmetry, and the crease wouldn't change the points. And then we have this one, which shifts over here. And this one kind of flipped it like this. We will normally deal with whenever we're doing these on other functions, we'll normally deal with the x-axis reflection, where the negative is sitting out front. That's the one that's going to be more common later on. On your homework, you will have some that are the negative inside, just to kind of exercise that skill. But long term, we're going to care a lot more about this one here. All right, moving on. Horizontal stretches and shrinks. A horizontal stretch or shrink happens whenever there's a variable inside the parentheses, and it is stretched or shrunk by the reciprocal of that constant. And I'm sorry that this looks kind of ugly. Then the vertical stretch or shrink is whenever the number is out front. In it, you don't have to deal with the reciprocal with it. Whenever the number is more than 1, we think of it as a stretch. It makes it larger. If it's less than 1, it's a shrink. It makes it kind of smaller. All right, so let's move on. We're going to have part A and part B again. I'm going to go ahead and just graph the original. It's the same original that we've been using so far. All right, there we are. There's the original. Now for A, the graph is f of 1 over x, or excuse me, 1 over 2x, where it's inside the parentheses. So this is going to be a horizontal stretch, and it's always the reciprocal. So it's going to be a horizontal stretch by 2. So we'll call it an h stretch by 2. And then we have the 2 sitting out front, and that one's a vertical stretch by 2. Now, I'm not going to actually graph this. We could. This would be graphing the function, what would this could be? G of x equals 1/2 x plus 2. And the other one would be h of x equals 2x plus 4. I'm not going to graph those for real, but I want to show you what would happen. For a horizontal stretch, it's like you grab the edges and you pull them to the left and the right. So we know that it would do something like, oops, it would do something like this. We would kind of pull it to be something more like that. For a vertical stretch, it's going to take the bottom and pull it down, the top and pull it up. And what this would end up doing would be something more like that. Now, the way that I got these functions that I wrote here at the bottom is that I plugged them back into the function f. F of 1/2 x says put a 1/2 x anywhere there was an x. So I put a 1/2 x there instead of a plain old x. For h of x here, it says 2 times f. So this was 2 times x plus 2. And then when you distribute the 2, you get 2x plus 4. Okay. For these, for stretches, you normally don't just count over. You normally actually do another t-chart and you kind of graph them that way. Moving on, these are going to be a whole lot like some of your homework problems. It's going to have your function f and then your transformation here. We don't care at all what the function was. We care about the transformation. So we care about really just this piece right there. It says f of x minus 2. That minus 2 means down 2. That's all we need to say. We just need to say that took whatever the function f was and it shifted it down 2. Next up, we have a negative sitting out front of the f, right? I'm looking right here. That's going to be a x reflection, an x-axis reflection. This one, there's a 6x and it's inside the parentheses. So this is going to be a horizontal, and then we have to decide is it going to be a stretch or a shrink. It's going to be 1/6, which is less than 1, so this is going to be a horizontal shrink. Right? Whenever it's in the parentheses, you have to take the reciprocal. Next up, we have a 2 sitting out front. This is going to be a vertical stretch by 2. We have x minus 1 inside the parentheses, so this is going to be a shift right 2, right? Or excuse me, not 2, 1. A right 1. It's a 1 there. And then lastly, we have 1/6 times f of x. This is going to be a vertical shrink by 1/6. Right? It's a shrink because 1/6 is less than 1. All right, that is all. Make sure on your homework, whenever you're looking at these, you don't care at all what the function f says. You care what the function g of x says. You care what the new function says, whatever the new one is, and then it will describe itself using the function f, right? Just like that. All right, that's all.